and have be seated in the front rows. So it will be easy, to continue this event today. අපි මේ ආරාධනා කරනවා පිටිපස්සේ ඉන්න අයට මේ ඉස්සර තීරුවල ඉඩ තියෙන නිසා පොඩක් එන්න කියලා ඉස්සරහට මේ අපේ මේ ඉවෙන්ට් එක කරගෙන යද්දී ඒක ගොඩක් පහසුවක් වෙනවා මේ ඉන්න සීලුම දෙනාට මේ ළඟට ආවොත් ඉන්න කට්ටිය. Okay, again, very good afternoon to all of you. First, I would like to take this opportunity to welcome you all for this industry networking event. After the session, the workshop conducted in the morning hours for the IPC hand soldering final competition. First, I would like to welcome Mr. Gaurav Mujumdar, the Executive Director of IPC India, and Dr. Ajit Pasquale, the President, Sri Lanka Electronics Manufacturers and Exporters Association, Ms. Indumini Kodikara, Director, Export Services, Sri Lanka Export Development Board, and the Chairman, Advisory Committee of EDB, Mr. Manjula Alvas. And today we have a special guest, Mr. Willy Perila from GPV Group. He's the Vice President of Quality representing the GPV Group, and as well as all other distinguished guests representing all the EMS and OEM companies representing today. So, as you already know, so we are in the industry networking event from now on. So, from the today morning onwards, we had the final competition on IPC organized hand soldering competition. So at the end of today's event, the winner will be announced here, who will be representing Sri Lanka for the IPC World Competition, which will be held in this year, November, in Munich, Germany. And the lucky winner, or the skilled winner, or the talented winner, who has all the skill set and everything, who will be representing Sri Lanka in this competition. So this year, there's been so many companies, EMS companies participated in this event. I wanted to name them. That was, actually there's more than 10 companies participated in this event. 3S Fabrications Private Limited, E-Gravity Solutions Private Limited, Flintech Transducers Private Limited, GPV Lanka Private Limited, MV Electronics Private Limited, One Smart B Private Limited, the TNG Lanka Private Limited, TOS Lanka Private Limited, and nothing last, the Vario Systems Private Limited. And we must give a special thanks to the following entities for their special support given throughout this competition and the today's event. That is Sim Lanka and the JBC Tools for providing all the assistance and the necessary tools for this competition and the necessities in here. And also a special thanks should go to Vario Systems, GPV Lanka and Flintech Transducers Private Limited for their all the assistance to make this event a success. So, moving on with this event's agenda. So, next up is the address, the gathering by Ms. Indumini Kodikara, the Director, Export Services, Sri Lanka Export Development Board. Speaking of, Ms. Indumini has over 22 years of experience in multiple domains: market research, project management, administration, product development, export services, and regional cluster development. She currently working as leads the Export Services Division of the Sri Lanka Export Development Board, the premier organization for development and promotion of exports. She guides the contributes to services sector to uplift the exports in those sectors. She has served as a judge in local and international programs, including World Summit Awards, Manthan Awards, Western Province Best Web, and Iswa Bamiani. She has also contributed her expertise to so many national ICT projects. Ms. Indumini earned her Masters of Business Administration from the Postgraduate Institute of Management, University of Sri Javadanapura, and is a graduate of University of Peradeniya in Agriculture stream, specializing in agricultural economics. So I warmly invite Ms. Indumini Kodikara to address the gathering.
Thank you, Kasun. Right. Mr. Gaurav Majumdar, Executive Director of IPC and his team, and Dr. Ajit Pascual, President Slimia, and Dr. Anga Rodrigo, Head of the Department of Electronic and Telecommunications Engineering, and the staff of the Electronics Department and Academia, and distinguished guests, the participants, and the industry representatives. I warmly welcome all of you on behalf of EDB to this electronics assembly gathering workshop. I'm glad that we had a good session in the morning. 24 participants, I think, competed. So we'll be seeing the outcome towards the end of this session. So I would like to say, as EDB, the Export Development Board, the premier state organization for export development and promotion, so we always try to assist and facilitate the exporters. So this is one initiative. Like we had we had a discussion with IPC India last year as a result of that, and we are conducting this workshop in association with Slimia. And we have the Mr. Manjulal, who is the chairman of our advisory committee on electronics and electrical sector at EDB. So at the advisory committees, we discuss what are the strategies to take this forward. How should we develop the electronics and electrical sector? So as a result, and with the help of IPC, I'm glad that we were able to get the workshop done as discussed and as agreed. I mean, we didn't not do it, but we did it somehow or the other. And I would like to say a little bit more about EDB, what we do. And there are few areas, verticals that we support the exporters. One is on the promotion. We promote our sectors, especially this sector is, when we call it, through our overseas missions in other countries. Sometimes we participate in trade fairs, sometimes we arrange business-to-business meetings with the industry and with partners in other countries. That is part of the promotion. And we facilitate when they come across any issues. Similarly, for example, to say during COVID period, there were issues of getting curfew passes maybe. Then during the fuel crisis, we had to assist a lot of companies in getting the required fuel for manufacturing, because we cannot stop exports for whatever the reasons, because that is the backbone of the country. So we need to do that. So that's another. Then in terms of free trade agreements and maybe preferential trade agreements, we try to assist and bring in, increase our exports, to have win-win situations with other countries as well. So now in the morning we had this particular workshop, and we will see the winner towards the end of today. I would like to thank IPC actually, especially coming over here, spending their time, and with the team, bringing all the equipment, JCB Tools, I think I have to thank them as well for bringing in the required equipment for the participants to have the competition better. So with that, I'm not going to talk much. So I assure you that you will be benefited by this. We have 2 or 3 seminars today. You will benefit, just learn. And just we'll have to compete with the international market. So you need to have your standards, you need to have your certifications. So learn and get what the best out of the speakers in this afternoon. And I hope you'll have a fruitful workshop this afternoon. And I would like to congratulate all the participants who competed in the morning. And since still we don't know, but I will congratulate whoever will be the winner, who will get the chance to go to Germany on IPC sponsorship. Thank you very much, and I wish all of you a pleasant afternoon. Thank you.
Okay, thank you, Ms. Indumini Kodikara. Next up, the event will be addressed by Dr. Ajit Pasquale, the President, Sri Lanka Electronics Manufacturers and Exporters Association, the SLIMIA. Speaking of Dr. Ajit Pasquale is the founder and CEO of Paracum Technologies. He's a senior academic with close to 25 years of experience at the Department of Electronic and Telecommunication Engineering at the University of Maratua, the premier engineering university in Sri Lanka. He has served as the head of Department of Electronic and Telecommunication Engineering and also as the director for Center for Information Technology Services at the same university. He received his BSc Engineering degree with first class honors from University of Maratua, Sri Lanka in Electronic and Telecommunication Engineering in 1993, and his master's in engineering and PhD degrees from the University of Tokyo in computer vision in 1998 and 2001 respectively. So it's our cordial invitation for Dr. Ajit Pasquale to address the gathering.
Very good afternoon to all of you. First of all, we are in my academic at University of Maratua. Let me warmly welcome each one of you to University of Maratua first, and then the Department of Electronic and Telecommunication Engineering for this very important, I think the first time in this country, the hand soldering competition, facilitated by and driven by IPC and also supported by GPV Group and many other companies. Thank you very much for your presence today. I want to get the names correct. Mr. Gaurab Majmuda, Executive Director, IPC, and Dr. Kingsley Bernard, Chairman of EDB, who was actually present in the morning, and Ms. Indumini Kodikara, Director, Export Services, and Mr. Akila D'Souza, Deputy Director, Export Services, Mr. Chandan Isanayaka, Managing Director of GPV Lanka, Mr. Manjula Alvas, the Chairman of the Electrical and Electronics Advisory Committee, and Dr. Ranga Rodrigo, Head Department of Electronic and Telecommunication Engineering, and all the members from IPC who are facilitating the workshop today, and our special guest, Mr. Vire Pereira from GPV Lanka, he is Vice President Quality, and all the supporting partners like JBC Tools who have been actually instrumental in actually supporting this event. Thank you very much for your participation and support for this event. First, let me congratulate all the participants in the competition today. I think it's a unique competition. It's not something that everybody can actually participate. It's an extremely skilled art of hand soldering. I think regardless of who the winner is, I think let me congratulate each and everyone for participating, because that represents your courage, participating in an event which ultimately will lead one of you to represent the country in the World Championship to be held in Munich, Germany, again sponsored by IPC. Thank you very much, IPC, for sponsoring that. So when we talk about electronics, I think as President Slimia, so I need to actually talk about basically, I mean, we all know that the greater majority of population, probably 99.99%, are users of electronic products. I mean, we only know that, but hardly do they know that what sort of processes that you need to actually go through in order to get a product out to the market, to the user's hand. It's a very rigorous process, and we have to comply with the standards. And I think only a very small minority is aware of that, the whole process. I think as SLIMIA, as the industry body representing the electrical and electronic sector, we need to take a lot of effort to make people aware. I mean, not to make everybody aware as such, but there are a lot of people, particularly the young, from the school children, to show that there is a career path specializing in this. So it's a skill once you acquire, and you are assured of a job, definitely in many parts of the world, not only in Sri Lanka. And today we are actually talking about AI taking over jobs. I mean, rest assured, I can say that anybody who is skilled in soldering will not actually need to fear about that one, because I don't think AI is going to take over that particular job like in the foreseeable future as such. So you are in actually good hands, and your future actually is pretty much safe in that respect. I think we need to further build the capacity in Sri Lanka, particularly on that side. And the help of IPC in that regard actually is extremely valuable. And I would like to thank again for promoting this event, because this is a place where I actually give that awareness to the whole community who might be looking at us in this sector. And again, we are representing a very important segment of the industry in Sri Lanka. So we are SLIMIA, we are 100 plus companies employing more than 38,000 people. And SLIMIA, or basically the member companies, contribute $483 million in 2022 to our export revenue. So we got biggest, or the fifth largest contributor to the export revenue. So we are actually bringing a lot of foreign exchange. I think this is only a fraction of what we are capable of, in my honest opinion. So it's just a matter of exploiting, or basically try to making use of many opportunities out there, and event of this nature facilitate that awareness, and finally actually getting more and more people attracted to this very important sector, because everyone, regardless of where they live in this world, make use of electronic products. It's not something that I don't think any other field actually can boast about, because regardless of your class, you will have at least one electronic product in your hand in today's context. So it's basically a massive market, and what we are catering right now is only a fraction of that total demand. And there's a lot of potential, untapped potential, I would say. So these type of events with actually create the awareness and also actually make people interested, we need to continue this. And I hope this event actually will be the starting point for creating this awareness in a continuous manner. And we would like, as SLIMIA, would like to actually continuously engage with IPC and as much as possible, and take the message to particularly the colleges or the universities or technical colleges who are actually producing the diplomats or the engineers in this particular field. With that, let me also touch on something I thought actually extremely important, because as an industry, we also actually face this with what we call this brain drain today, okay? And many people actually live in the country. So not exactly. So this is sometimes something actually puzzles me. Like they may be going, but whether they actually will be ending up in the type of job that they really want to do is something questionable. So how do we really make or retain? How do we actually create brain gain as such, rather than facilitating brain drain due to obviously things out of our control? So as a SLIMIA, as the main industry body, and all the supporting like organization like IPC, like EDB, so what we need to do is to create that conducive environment for people to stay here and understand that, okay, by living here, I mean, you have a extremely good future. That's obviously, there can be short periods of uncertainty, but then if you decide your future based on that very short period of uncertainty, I think probably you are making a big mistake. Okay? So that's something that we need to also keep thinking about. So let's hope that as the industry body, and also and the EDB, and probably EDB representing the government, will take measures to build or instill confidence in all of us, all the people actually who are already employed in the industry, and also who are looking forward to come to this industry like in the future. Because they may be students, in few years' time they may be like entering the industry. So we have to, make sure that the industry is considered as a very robust, reliable industry that will be there's only upside movement, not downside movement as such. Given that we are representing one of the biggest industries in the world, and obviously from a consumer point of view, one of the most important industries, I think we have a lot to achieve together. Okay, so with that remark, let me conclude my talk, but I would be failing in my duty if I don't actually mention few people, because without them, today's event actually would be kind of a dream. First, for GPV basically for supporting this and JBC tools, and particularly Mr. Lalit Bandara from GPV Lanka is a kind of backbone of this entire event. And I don't think anybody actually, if Lalit is not there, I don't think this event actually would be here today. And also, let me thank Dr. Angela Rodrigo and the Department of Electronics team to facilitating this, and also Center for Instruction Technology, Sanjay Suryarachi for video recording this event and live streaming this event, so that other people, actually those who are outside but very much interested in this field, can really see what is happening here. Thank you very much once again, and have a pleasant evening. And let me also, in advance, congratulate the winner of today's event, and hope you can actually bring the cup to Sri Lanka. Thank you very much.
Thank you very much. And that was Dr. Ajit Pasquale, the President, Sri Lanka Electronics Manufacturers and Exporters Association. Next up, we have an interesting session that will be conducted by Mr. Vittal Vatar, the Regional Manager IPC for South India, Sri Lanka and Saudi Arabia region. He'll be conducting this session on Introduction to IPC.
Very good afternoon to all. As Kusum mentioned, I am Vittal Ayyappa Vatar. I am working in IPC as a regional manager South India, and also taking care Sri Lanka and Saudi Arabia region. In this opportunity, on behalf of IPC, I want to thanks to EDB, Sri Lanka Export Promotional Board, and SLIMIA, and I want to thank to University of Morotava for helping us to successfully conduct this event today. Today I'm going to present you about two topics. One is with IPC and IPC activity from the global point of view, and also I'm going to tell you about India electronics growth. Is this happening? What is happening? No. Can you help me with this? Before that, I want to show you a short video about IPC activity worldwide.
Your goal is to build fully functional, highly reliable products in a rapidly changing world. Failure is not an option. To achieve this, you need a trusted source to identify growth opportunities, develop solutions to your technical challenges, and help mitigate supply chain risks and public policy, and lobbies for the reforms you need to be successful at what you do best, manufacturing. IPC exists to help the industry create better quality products, enhance costs and waste, and influence policies that spur innovation. IPC has become the voice of industry, and as we keep our eye to the future of technology, IPC is the voice of what is next.
Thank you. I think with this introduction video, you must have understand what is an IPC role worldwide. I'm going to touch base some points on this introduction. Yes. IPC started in 1957 as an Institute of Printed Circuit, with 6 companies joined hands together and started writing standard. Now there is no expansion for IPC, but IPC is build electronics better. IPC is a global non-profit association serving worldwide with 70 plus countries. And IPC major goals are education and standards. Normally standards are designed and developed by the industry and followed by the industry. With the standards, IPC has created a curriculum training certification which is recognized and follows worldwide. And IPC also helps industry to come across their issues, problem solving challenges from the industry. And IPC is known to conduct networking event called Apex Expo, world US #1 show in US. Yeah, this is very important. IPC is totally working with 5,000 plus members worldwide. Our major contribution comes from the OEMs from defense, aerospace, medical, and we have next to the EMS sectors and EMS and contract manufacturers, and next comes to the next comes to the supplier and equipments, and we have members from government, education, and non-profit associations. Yeah, these are the, IPC works with 60 plus committees to develop the standards worldwide, and if you see all important OEMs is part of our committee. You can see NASA, Honeywell, Airbus, and medical, defense, all our members are part of our committees. Yeah, IPC has started its journey in this region from 2010, and we have been serving in India, Sri Lanka, Bangladesh, country in Middle East, South Africa, and we have a dedicated training center office in Bangalore and Delhi, Chennai, Pune. And we are working with 15 voluntary instructors. They are working with us from last 10 years, and they are all master IPC trainer in IPC. And we have been certified almost 13,000 certification in last 12 years. They are from the large MSME and government companies are part of taken our services. And when it comes to education, we have 400 plus standards, which is designed and developed by the industry. Out of 400 standards, we have training on design, assembly, fabrication, repair, rework, and this is recognized worldwide. And very recently, IPC has introduced trainings for the beginners from the students, and they have 0 to 3 years experience in the electronics, wire harness, and engineer level. Here I'd like to take an opportunity to show you another video, which India ESDM story, which our Narendra Modi is initiated from last 8 years.
Speed, scale, and speed. Under the charismatic leadership of Honorable Narendra Modi and his visionary initiatives, India has witnessed an unprecedented growth in the electronics manufacturing in the last 5 years.
India aims to become a $400 billion electronic manufacturing industry by 2025. Efforts of industry and proactive approach of the government have brought about an enormous growth in past 5 years. This has enhanced India's share in global electronics manufacturing from 1.3% in 2012 to 3% in 2018. India has emerged as world's second largest manufacturer of mobile phones in the world. The mobile phone production has gone up from 60 billion units in 2014-15 to 313 billion units in 2019-20. The number of units involved in manufacture of mobile phones and their sub-assembly parts from 2014 to 200 units in 2019. Production of other electronic goods has also gone up significantly. The manufacturing of LCD LED TVs in India has grown from 8 million units in 2016-17 to 12.5 million units in 2019-20. And today, 38 units are producing LCD LED TVs in the country. Modified electronics manufacturing facility 2.0, worth $550 billion shall provide a financial assistance of 50% of the project cost for setting up of EMCs and CFCs with plug and play infrastructure. Come and be a part of the mega electronic revolution in India, which provides a huge growth potential and an opportunity to thrive.
Your goal is to build fully functional.
Sorry. Thank you for watching. Yes, we understand how Indian ESDM is growing from last 8 years. We have a lot of new clusters coming in all over the India. I want to just glance you some slides about this video. Yes, India, we are working towards to achieving $500 billion target in 2025. And our major areas are consumer electronics, and we are in number 2 mobile manufacturers. And we also work, India is working towards electronic, industrial electronics, computer hardware, and defense and aerospace sectors. If you see when electronics is growing and India is, sorry, when electronics is going, and definitely we believe that we are importing a lot of PCBs from other countries, and we have some overviews that we have taken almost 2.8 billions of PCBs to touch base in all the sectors. And this is the major key areas of electronic clusters, which is India is developing. From the north, we have Noida, Greater Noida, Gurgaon, and Tamil Nadu, Chennai, and Sriperumbudur, and we have in Andhra Pradesh, Maharashtra, and Telangana. In this context, IPC is started building a networking events to bring Indian OEMs, global OEMs, to help our members behind our certification. And we celebrated last year our 10 years journey with the theme of Integrated Electronics Manufacturing Interconnect with the two cities in New Delhi on August 2nd and Bangalore on August 4th. We had a good interaction with 1,200 delegation from international and India as well as. And we had a delegation from Singapore, UAE, Qatar, Sri Lanka, US, and we have been successfully conducted 200 B2B sessions with the global OEMs and Indian OEMs. And we also had a successful 20 plus exhibitors, especially from the supplier side. They've been showcasing their product, and which is helping our members to select the right product for their manufacturing. And with this contest, we thought of rotating this event, and we have started our second edition, IMI, and we are moving to the Chennai and Pune. These two cities are doing really well in the sector of automotive, medical, aerospace, and defense. And these are the key areas, key programs we are seeing in this IMA 2022. Yes, definitely we have business networking program, technical session. Technical session, again, we have also confirmed with NASA and US Defense. They are part of our technical session. Definitely we are going to have a final skill challenge competition in India with hand soldering, wire harness and PCB design. And we also having a B2B events with Indian OEMs and global OEMs. We already got confirmation from Singapore, South Africa, Saudi Arabia, and we are hoping also getting a good contribution delegation from Sri Lanka. And we also have a vendor development program, which is also confirmed with the two global Indian OEMs, especially from defense and medical. And these are the key visitors we are expecting. Last year also these sectors, they're part of our visitor promotion. Yes, it is IPC, not conducting this event. It is being conducted with support with all the international associations. We would like to thank Slimia, who is a part of our event. Yes, and in India, we also have a very good support from the Indian association, like LCNA, FICCI, other part of national association will be supporting our events. They told that they bring their members to this event to make it successful. And I'll take an opportunity to thank our sponsors and exhibitors, those who confirmed for 2023 IMI in both the cities, Chennai and Pune, JBC, Advanced Tech, Mechatronics, RayQ, STL, and there are companies, EMS companies and wire harness companies also part of our exhibition. This is all about IPC and IPC activity. Thanks for this opportunity to address you people about IPC activity. Looking forward to help you in future. Thank you.
Okay, thank you very much for Mr. Vittal Vatar, the Regional Manager IPC for South India, Sri Lanka and Saudi Arabia for those valuable session. Next up, we have an interesting guest here today, especially for this event. He's originally from Finland. And he has his studies on Masters in Technology in University of Technology, Finland. And he's a Six Sigma black belt holder from 2004 onwards and a lean leader from 2010 onwards. He has his industry expertise in working in ABB for 12 years, ABB LTA in US and India, and ABB projects globally. And before that, he has 10 years experience in paper and chemical industry in various projects. And currently, he's working as the Vice President Quality for GPV Group since May 2020. So we cordially invite Mr. Vili Pirila for share your experience with this audience. much for your valuable thoughts, Mr. Vijay Pirla. So next up, we're going to move on with the agenda. So next up will be a presentation on best practices in electronic assembly by the Master IPC trainer, Mr. C.S. Nagaraj.
Good afternoon, everybody. At the outset, first of all, let me thank the organizers for having given me the opportunity to give the presentation in front of the academicians and the industrial personnel from Sri Lanka. So today I am going to present to you on the best practices that has to be followed for the electronic manufacturing and what are the IPC standard that is addressing those best practices. My address, the overview of the address would be the introduction to electronic assemblies, the IPC standards, electronic assembly constituents, assembly process, the tools and equipments, soldering through hole and SMT process, solder joint inspection, and handling of electronic products. As you all know, the electronic industry is widespread. Entire life, human life, it depends on electronics so much. You don't find any place where there is no electronics nowadays. So you have electronics everywhere, and behind the success of the products introduced to the market is a professional and reliable supplier will be a EMS company who manufactures this. The EMS companies includes manufacture, testing, and repair services of electronic assemblies, and the design houses offer the design services. These services are offered by EMS companies and design houses to the original equipment manufacturers. Electronic assembly involves process of PCB assembly, the wire harness assembly, and the box building. Companies involved in the EMS activities are to ensure their products and services meet the requirement of the customer. This presentation, I am going to cover briefly the best practices for the electronic products. Standards are a set of instructions, rules, guidelines that are followed in a process to ensure universally acceptable quality of the product. So these guidelines are developed by the organizations which are recognized, approved, and traceable. IPC is one of those organizations which provides guidelines. The IPC standards provides guidelines for the entire electronic manufacturing supply chain, starting from design stage to the end product. A manufacturer adopting the standards would automatically be following the best practices in the electronic manufacturing in their activity, and so they get evaluated better in their industry. So this is the depiction of electronic assembly area where you have the IPC standards addressing various activities of electronic manufacturing, starting from the design to the final dispatch of the product. There is another depiction of IPC standard tree where the standards which you see in the green blocks there, they are design standards. The one in blue are the PCB manufacturing standards. The one in yellow, they are the assembly standards, which deals with PCB assembly, then the wire harness, and also the box building. The one on the two sides, they are in the white blocks, they are the standards which supports the main standards in the various process that is followed in the electronic manufacturing. When it comes to the electronic assembly constituents, it has the printed circuit board, the electronic components, hardware, which includes connectors, heat sinks, wire harness, and fasteners. IPC standard describes materials, method, and acceptance criteria for producing soldered electrical and electronic assemblies, and adopting these standard facilitates to rely on process control methodology to ensure consistent quality levels at the manufacturing process. Any product, electronic product, is classified into three classes: class 1, class 2, and class 3. Class 1 is a general electronic product. Class 2 is the dedicated service electronic product like your telecom, your UPS, or your, any telecom products, UPS, like that. And then the high reliability product like your space, military, medical electronics, or even automotive, they are considered to be for class 3. There is a standard J standard 001 which describes the material, methods, and verification criteria for producing high quality soldered electronic assemblies. It emphasizes on the process control and also general requirement for handling, safety, tools, and ESD, placement and soldering process and acceptability criteria, test methods, and related applicable standards. Then other standard 610, which talks about acceptability criteria, which is the visual acceptability criteria that is followed in the industry for the assembled PCAs. This is a standard 620, which talks about the wire harness requirements. The details on 620 standard is going to be presented by my friend after this presentation. IPC standard facilitates cross-channel communication between OEMs, PCB assembly, and PCB manufacturers. Not only that, even within the organization. Everybody knowledgeable about IPC standards, in a shop floor environment, there will be always conflict. The inspector says it's not acceptable, whereas the manufacturer, the production man says it is acceptable. There is always a conflict between the two groups. So if everybody follows the standards and they understand the requirement as a common language, then that conflict can be resolved. So it helps in builds customer trust and enhances customer satisfaction, confirms the validity of the PCB product, contributes to the growth of electronic manufacturing. Obviously, you manufacture a reliable product, your growth is ensured. Printed circuit board is a basic substrate in which electronic components are mounted and interconnected by soldering. So there are different types of printed circuit boards, which they are single-sided, double-sided, multi-layer. And again, based on the substrate, it can be rigid, flexible, rigid flex PCB or metal-clad PCBs. Again, types of PCBs can be type 1 to type 6 based on different configuration on the layer formation. And even flexible PCBs are from type 1 to type 5. So printed circuit boards, what you receive for assembly, they need to be inspected as per IPC 600. 600 is the quality standard for bare PCBs, and the qualification performance of the PCBs manufactured by your vendor has to be following 6010 standard, which is 6012 is a rigid PCB, 6013 flexible PCB, 6015 MCML, and 6017 embedded PCB, 6018 is a high frequency PCB. So the manufacturer vendor, PCB vendor need to follow the IPC standard so that your final product will meet the final requirement of the customer. Then, when it comes to the components, there are through-hole components and the surface-mountable components. Then assembly types, there are type 1 to type 1A, type 1B, type 1C, type 2B, type 2C. So type 2C is the PCB assembly with mixed technologies, which is the order of the day now. You have all the PCBAs with mixed technologies where you assemble both through-hole and SMT components. So adopting standards necessitates the manufacturer to implement process control as part of the quality management system. As a part of your quality management system, you have to adopt the process control at every stage, starting from receipt of raw material to processing the raw material and finishing and handling everything. Throughout the process, every stage, you have to have the quality management system has to address that, and standards will help you to follow that. A system or method to continually steer an operation in reducing variation in the process or products to meet or exceed the goal in quality and performance is the goal of any process control system. So a process control document need to be there for every operation, which you call it as a standard operating procedure or whatever you call in your organizations. So the process control document that should not only address the process, the way that is processed, but it also should contain the information of how to correct if something goes wrong. So when you're following the standards, there can be a conflict again. In the event of any conflict among the documents, various documents followed in the manufacturing, there can be a conflict between the documents. So the procurement document always stands the precedence. So followed by the master assembly drawing and then the standards. The products that you use for manufacturing need to be procured from an approved vendor. There is an IPC standard, IPC QL 653, which establishes certification requirements for where it will tell you how to certify your vendor. Establish certification requirements for facilitators that inspect, test, and PCBs, components, and materials. This specification is intended to provide a minimum standardized basis for evaluating or auditing a facility. So you can follow this standard to audit or evaluate your vendors. So once you place an order on the vendor, you receive the material, you have to ensure that the PCBs or the component received are inspected at the incoming inspection and ensure the material received meet the specification. There are reference standards for components, J standard 02033 for MSD, IPC 1602 for PCB handling and storage, and again handbook 001 and IPC AJ 820. These are the reference standards that can be followed. PCBs, I'm talking about the bare PCBs that are received with the certification of confirmation on the performance parameters as per IPC 600 or 6010 family. So your vendor need to give you a confirmation on the quality, performance, and a confirmation certification has to be obtained if you are manufacturing to a high reliable product, electronic product. It is a must that you should follow the process. The reports on microsection of coupons and visual inspection of mechanical dimension and internal characteristics as per acceptability of IPC 600 and 60 family standards are to be verified. PCB is confirmed to solderability as per J standard 003. J standard 003. So the PCB is what you receive need to be certified that it is solderable. Otherwise, you will not get a good solder joint. Similarly, the components are to be solderable and it has to be verified as certified as per J standard 002. These are the two standards. Next, coming to the solder alloy itself, there is a standard J standard 006 which talks about leaded, lead-free and high temperature solder, which will help you to select the correct solder alloy required for your requirement. Solder paste selection will be as per J standard 005. If in case you are using a lead-free solder, which is a requirement for manufacturing to the Western countries, it has to be, they demand the lead-free solder to be used. I hope all of you are using lead-free. Some of you are using lead-free soldering. So, if you are a class 3 manufacturer, if your product are manufactured to be manufactured as per class 3, you should adopt a lead-free control plan. This is concerned with mitigating tin whiskers, because in the lead-free alloy, there is a lot of tin. 96.5% tin is there. So this tin, too much of tin will result in tin whiskers. Tin whiskers are, this, you can see this, there is a tin whisker which can, over a period of time, there is a growth of tin and it can bridge the two conductive patterns. So that will affect the reliability. For a class 3 product, you should have a process where you can mitigate this possibility of tin whiskers. Again, J standard 004 is the standard for selection of flux. Flux is again an important consumable that is used, ingredient that is used in the soldering, which will help you to get a better quality solder. Again, soldering process. Coming to the soldering process itself, it is the process of joining any two metal surfaces with the help of a filler material. Filler material is nothing but a solder alloy here. So there is an intermetallic layer that is formed between the solder alloy and the basis metal, that is a copper. A thicker intermetallic layer would lead to crack in the solder joint. So this is again for a high reliable product, which undergoes high vibration, there can be chances of the solder joint getting cracked if this intermetallic layer thickness is not controlled. You can see what is the intermetallic layer here. It's not playing. It's not playing, yeah. So intermetallic layer, thicker intermetallic layer will lead to crack. So that is the reason why when you are doing a soldering, you have to control the time and the temperature. More amount of tin or any other material that is getting into the solder joint, into the alloy, there is the intermetallic layer that is formed, it becomes thicker. So usually 1 to 1.5 microns of intermetallic layer thickness or less than a micron is desired. If it is more than that, due to vibration, there can be cracks in the solder joint. So high reliable product need to be take care of this. You will not know when there is a solder joint crack how it has failed. It may be because of that. Too much of rework may lead to that. Frequent rework may lead to that. So the solder alloy used may be tin lead alloy or lead-free alloy. Soldering process, that is the reason normally you have the gold, you have the surface finish which is hot air level, which is coated with solder. And nowadays with the advent of SMT components, there is a finish which is called ENIG, electroless nickel and immersion gold finish, which is given on the gold plating. So if there is a gold plating thickness is more, if there is only pure gold, if the gold plating thickness is more, too much of gold getting melted into the intermetallic layer there. So the bonding, the intermetallic layer between the copper and the gold, or the copper and the gold there, is very weak when compared to copper and tin. That is the reason 95% of the gold has to be removed before the gold, you do the soldering on the surface. The standard recommends that. Okay. So 95% of gold from the solderable surface to be removed. It is done by double tinning method. It is exempted from the above process if there is no evidence of gold embrittlement or solder joint integrity problems, and the plating is with ENIG or any other. Where the gold plating, they control the gold plating thickness, they restrict it to only about 0.5 or 1 micron. If it is more than 2.54 microns, you may have to remove the gold. Soldering process can be by hand soldering process used for prototype or small batch productions, reflow soldering, wave soldering, selective soldering, or intrusive soldering or robotic soldering used for machine soldering, for bulk productions, resistance and induction heating is for assemblies of components where normal soldering process is not possible. Whatever be the process of soldering, the solder joint has to be as per the standard. The stages of a PCB assembly process are pre-assembly stage, which is kitting, preparing the PCBs for assembly, which is preheating, cleaning, and lead preparation. Then placement and soldering stages, which include stuffing of the components, soldering, it can be manual, wave solder, selective, robotic, reflow, and inspection, which can be visual inspection, AOI, or even X-ray. Then post-soldering stage is cleaning, conformal coating, and encapsulation. Then inspection can be followed by electrical testing and rework if required. Kitting, components picked from the stores, verified and kitted as per the bill of material and issued to the production. I hope there is a kitting section in all your EMS companies. You follow that? Yeah. Then, baking of PCBs. Why baking is done? There can be absorbed moisture if the PCBs are not stored properly. So the PCB, the absorbed moisture will have its adverse effect on the soldering. So PCBs need to be baked to remove all the volatile substances from the surfaces or the holes that may interfere with the acceptable solder joint. Usually it is baked at 100 to 125 degrees centigrade or even under vacuum condition before the assembly. So boards are placed inside. When you do the baking, the boards had to be stacked vertically. You cannot stack it one over the other. If you stack it one over the other, the moisture cannot escape. So you have to stack it vertically with space in between, and the oven need to be, with good air circulation, so that, and the environment in the oven should not contaminate the PCB surface. It is the best practice to pre-bake the PCBs before soldering process to prevent the ill effect of moisture and other volatile contents in the PCB. For that, there is a standard IPC 1602 and J standard 033 for handling and storing procedure for PCBs and MSD components. Pre-assembly, lead preparation. Leads, termination, or boards not meeting the solderability requirement may need to be reworked before soldering. So ensure that the components and the PCBs are solderable before you actually start doing the soldering. The rework part shall conform to the solderability requirement as per J standard 002 or 003. You can see this picture where before rework, and it is made, the oxidation is removed, and after rework, you can see the clean, solderable part there. Then lead forming in a through-hole component. Through-hole component can be, PCBs can be of two types. One is the supported with a supported hole, and other one with a non-supported hole. Supported hole is the plated hole. Unsupported hole is without plating. Whatever be that, leads are formed to help the placement of component into the designated holes with proper bend radius. You have to have a bend radius when you form the lead. I hope today, when you place the component, through-hole component into the PCBs, the participants should have taken care of this, the bend radius. Okay. Components meant to be placed above the PCB need to have leads formed. This is usually given by the drawing. The designer would have said that component need to be placed above the PCB. Then you have to maintain a 1.5 mm gap. Minimum distance of 1 lead diameter to be maintained from the for forming the lead so that there is no damage to the component or lead. Then it meets the height requirements. Components need to be mounted, needs mounting, having clearance from the PCB surface should be 0.8 to 1.5 mm. Components like LEDs, switches, potentiometers mounted without any tilt. You have all mounted LEDs today? How many of you are mounted with tilt? That was considered. So there should not be any tilt. And there is a gap, there is a gap of 0.3 to 2 mm that is to be maintained throughout. And it is not to be mounted flush. If it is mounted flush, what happens? There cannot be any vertical fill inside the hole. When there is no vertical fill, there is a requirement of at least 75% of the whole barrel to be filled. And if it is not filled, it becomes a defect for a class 3 product. The tools and equipment, you have to select the correct tools for the hand soldering, maintain the tools and equipment and text fixtures with calibration done periodically, use authorized tools only, document detailed setup. You have to have an operating procedure for operating your tools, and that has to be followed meticulously. Have process tooling and equipment validated for the process. Soldering iron equipment systems used need to provide temperature control. There should be a temperature control. How many of you changed the temperature setting? I don't think anybody changed the temperature setting. Temperature need to be changed for the component, based on the component and the size of the lead or the pad. The component, the temperature need to be, and you need to correctly use the correct temperature. Otherwise, you result in, it gets resulted in overheating the PCB and spoiling the PCB. So when you are especially manufacturing a class 3 product, all these things are a must. Again, tip selection. Correct size of tip has to be selected, which is equal to the size of the pad that is being soldered. If you take a bigger size tip, you may damage the PCB or the pad may get lifted. Smaller tip, you may have to heat it. It will take long time to the pad to get heated. Thereby, your soldering time is more. So any soldering time should not be more. It should not be more than 2 to 3 seconds. Within 2 to 3 seconds, you should be in a position to get a good solder joint. Some people could not complete the soldering. 55 minutes were given. People could not complete it. The reason is this. So the time, they have spent more time in soldering. So this has to be borne in mind. PCB soldering process by machine soldering needs again preheating. It is to minimize the presence of volatile contents, to protect from thermal shock. This preheating also will help you to ensure there is no thermal shock to the PCB. If you suddenly heat the PCB to 250, 260 or 300 degrees centigrade, there is a thermal shock thereby the PCB may get delaminated or there can be blisters. So to avoid that, you may gradually heat it. So the preheating may help you to protect the PCBs from any thermal shock, to improve solder flow, to achieve the vertical fill, then to reduce the dwell time above the liquidus temperature. I told you 2 to 3 seconds. Should not be more than 2 to 3 seconds in the liquidus temperature. Temperature, what that is selected, should not degrade the PCBs, and the control cooling process, if used, should be as per the documented procedure. You should not as you gradually heat, even cooling should not be sudden. It should be gradually, it should get cooled down to the room temperature. Suppose you have a component which is thermally sensitive, heat sensitive. Such components, when it is subjected to heat, probably what will happen? The component will fail. So you have to drive away the heat from the component, thereby by adding a thermal shunt, connecting a thermal shunt like this. You have to drive away the heat from reaching the component. Then define and maintain applicable operating parameters, validation and procedures for machine soldering. That is the process control. Identify adjustment of settings for different assemblies. Limit exposure of printed board to solder bath to a duration that will not degrade the board. The solder bath temperature based on solder alloy in use. Tolerance for temperature setting can be plus minus 5 degrees centigrade. Parts not compatible with the process temperatures are to be mounted manually and soldered separately. Suppose you're doing a wave soldering and the component cannot get soldered in the wave soldering. Such components you can mount it separately. A time temperature profile has to be followed, and you have standard IPC 7530 which provides the guidance for developing a type temperature profile for a PCB assembly. Again, there is another standard IPC AJ 820 for guidance. So this is a time temperature profile. This is the preheat. This is the preheat soak. This is your reflow temperature. This is your time above the liquidus where it gets soldered. Then this is your cooling zone. Okay. Wave soldering is a process of soldering PCB assemblies by passing the stuffed PCBs over a wave. As the circuit board makes contact with the wave, the components get soldered to the board. Wave soldering is mainly used in soldering of through-hole components. Wave soldering can be used for soldering surface mount by gluing the component to the PCB surface. The process cycle followed are, again, preheat, soak, fluxing, second preheat to evaporate the flux, then ramp up, soldering, then cooling. So this is the time temperature profile. Similarly, selective soldering, it is a process of soldering individual component through the components on a PCB using a solder fountain. Instead of a solder wave, you have a solder fountain where individual leads are soldered. The solder fountain or head is programmed. You can program this equipment where it can go to the corresponding lead there and solder that joint. It offers a low-cost approach over wave soldering when soldering through whole component or mixed technology PCBs. So this has got some advantages over wave soldering. The solder bath has to be analyzed frequently, and IPC J standard 001 and 610 gives you the contamination level that is allowed for solder bath, so that can be maintained as per that. So whatever be the type of solder joint, soldering process that you follow, these are the acceptable solder joints. There is a vertical fill, then the circumferential fillet on the solder destination side, and then land area coverage on the solder destination side, Then again, on the solder source side, the coverage. This is the acceptance criteria, and IPC 610 and J standard 001 gives you the criteria for class 1, class 2, and class 3 products. Components need to be secured when it is subjected to high vibration. So to relieve any stress on the solder joint, it can be adhesive bonding, clip mounting, or clamp mounting. And if you use adhesive, it has to be as per IPC SM 817. Coming to machines, SMT soldering, the steps involved are solder paste printing, solder paste inspection, pick and place, reflow, inspection, AOI or visual, cleaning, and final inspection. So SMT devices are mounted on the surface of the printed board. So components are available in package and reels, tubes, and trays. The first step of the SMT process is application of solder paste. The solder paste printing is the very first step, where the solder paste is squeezed through the stencil or by even jet printing. Solder paste inspection is another process which has to be followed. It is a very important process. If there is any deviation in the solder paste printing, if the correct volume of solder paste is not printed, then it may result in a bad solder joint or a defective solder joint. Inspection systems can be, solder paste inspection system can be even 2D or a 3D. Improper control of the process can be a major attribute to the solder defects. Again, IPC 7525 standard provides guidance for design and fabrication of stencils. 7526 provides guidance for stencil misprinted board cleaning. Then 7527 provides solder paste printing guidance. Then J standard 005 provides information about solder paste itself. Then you have a test method, J standard 005 TM 650 2.4.43, which will give the guidance for checking the solder coalescence, and a poor solder coalescence may lead to a bad solder joint. That is why solder paste that is used for more than 8 hours need to be discarded. Component placement, use a pick and place machine, automatic machines which are having nozzles and this thing where it can place about 80,000 components per hour. And wrongly placed components soldered into position can be costly and time consuming, so it needs to be properly programmed and correctly placed. Coming to placement of chip components, there are SMT components, there are chip components, then the castellated terminations, then the gullwing component, which you people have assembled today, then this is a DPAC, and these are various types of SMT components that are mounted. And IPC 6, this is a BGA, ball grid, column grid, or land grid array, where the inspection is done by X-ray method. So IPC 610 and J standard gives you the criteria for inspection and any misalignment, allowable misalignment when you place the component. Voids in the solder joint in a BGA, collapsible ball, is about 30% as per standard. And of course, if a customer wants less than that, your process should ensure that you have maintained that required limit. Again, PCB reflow soldering. It has got a preheat zone, a soak zone, reflow, and cooling zone, similar to what we saw earlier. This is the hand soldering process of a this is how it is done. I hope people today who have worked with this have followed this. This is the right way of doing it. This is another gullwing component. This is soldering point by point. Then another method is called the drag soldering, which I have seen some people are attempting it and getting, it was resulting in shorting of the leads. They were finding it difficult to remove the shorts. I observed that. And of course, there was no damage that was done to any of these boards. It may even result in damages if you apply force there. A drag soldering is also shown here. This is by point by point. So, again, solder joint, when it comes to inspection, solder joint meets the requirement of the standards 610 and J standard. It has to have a solder fillet less than or equal to 90 degrees. More than 90 degrees are allowable only under exceptional conditions. Acceptable the quality aspects, there are conditions: acceptable defect, process indicator condition. A process indicator condition needs to be mentioned and monitored very closely because it indicates that there is something wrong in the process. So some customers, especially class 3 product, they may not accept process indicators at all. They say no process indicators are allowed. So then at that time you cannot say standard says process indicator is allowed. No, you cannot. So you have to go by the customer requirement. So these are the various quality aspects with respect to misalignment of SMT components, and all your products which were assembled today has been inspected as per class 3 of 610. Then post-soldering, we have the cleaning process. There is a standard IPC CH65 which tells you the requirement for the cleaning, which will help you to set up your cleaning process also. There are test methods, TM650 test methods, which will guide you to check the cleanliness of the PCBs. Customers, especially class 3 products, they will ask for a particular level of cleanliness. Then you have to maintain that cleanliness level. Then evaluation for cleanliness will be as per ROSE. Test ROSE is resistivity of solvent extract method. Then objective evidence can be, you have to have an objective evidence where data pertaining to field failures, failure analysis, data evidencing causing of failure not attributable to the cleanliness. These are the data that you have to maintain apart from doing the evaluation by ROSE test for a class 3 product. Cleaning agents, again, go as per IPC CH65. Ultrasonic cleaning is not allowed on assembled boards. Then conformal coating. It is a thin polymeric coating, a protective coating applied on PCBs to provide a protection to the components and solder joints. It can be by brushing, spraying, dip coating, or even vacuum coating, depending on the type of the process that you adopt and the type of material that you select. So you have to maintain a thickness of the coating as given by the standards, depending again, that depends on the type of conformal coating material. The selection of conformal coating material is also as per the requirement by the customer. It again depends on the end environment where the PCBs or PCB assemblies are used. So only area designated has to be conformally coated, which is not to be coated has to be masked and are inspected under a UV light. Then when it comes to handling of PCBs, starting from your kitting stage to the final assembly and testing stage, throughout the process, handling procedures for components should ensure that contamination, damage or degrading of the components is not there, and protect the components and assembly from failure due to ESD. The recommended practices are always handle electronic assemblies at properly designated areas, that is the EPA, that ESD protected areas. That ESD protected areas must be checked periodically as per ANSI ESD S2020 is the standard. Proper ground, you have to check for proper grounding methods, static dissipation of work surfaces and floor areas, operation of air ionizers. Then work areas are free from static generating charges. Work areas must be kept clean, neat to prevent contamination. When not being worked, sensitive components and circuit boards must be enclosed in a shielded bags or boxes. PCB, PCAs are components that will be handled only by edges, avoiding touching of the components. Hand creams and lotions containing silicone shall not be used. Staking of circuit boards assembly should be avoided to prevent physical damage or even ESD damages. So that's about assembly, starting the entire assembly process. I just covered only the basic requirements that is to be followed. Of course, with a short time, I could not cover everything. And IPC training, as Mr. Vittal already told you, that there it covers the entire process of the requirements. Various criteria are discussed there, and the acceptance criteria and the non-acceptance criteria are discussed there. So it helps in cross-channel communication between OEMs and EMS. The training will help you to promote compliance and enhancing quality. It helps build customer trust. It is a manifestation of willingness to invest in industry professionals, contributes to the growth of electronic manufacturing. So with this, I conclude. Thank you very much. I don't know.
Okay, thank you very much, Mr. C.S. Nagaraj. There's been a lot of information shared to you, and I hope everything will be beneficial in your work life. So the next presentation is on wire harness, a growing sector in electronics, by Master IPC trainer, Mr. T.N. Panishari.
So, good afternoon, everybody. Anyway, I'll just, this is almost like a continuation of what Mr. Nagaraj was already speaking on this. So, wire harness is essentially, though it may be passive circuit, but it constitutes one of the important aspect, like it is the connecting medium between different active functional units. So the main thing here is, for any equipment to or machine to function, three things are there: power source, functional devices or modules, and of course the interconnections between them. The interconnections can transmit power from the source to the functional units or transmit signals from unit to unit. So in modern day equipments or machines, interconnections are achieved by wires and cables with suitable terminations, assembled and routed as per requirement of each equipment or machine. This prefabricated wiring assembly is known as the wire harness. So of course, in almost all sectors, we are using this wire harness. Now, as the sectors grow, the demand for wire harness also is continuously growing. So with widespread use of the wire harness requirement for the industry, standards in manufacturing is of utmost importance, and IPC and Wire Harness Manufacturers Association partnered to bring out standards applicable to wire harness. So this next we are going to see this various different standards applicable specific to wire harness. Here you can see there is a design standard for wire harness, then the handbook HDBK, then the acceptability standards, then also 640 is for the fiber optic cables. Of course, these next standards were already referred. Solderability for wires and leads and terminals, that is J standard 002. For fluxes, it is J standard 004, and for solders, J standard 006. So coming to some important, of course, this is one of the most popular standard for as far as the wire harness is concerned because of the quality acceptability requirements of that. So this anyway is a very big or vast subject. I'll only briefly cover some of the points here. So here the standard addresses how to control the tools. So all tools and equipment controls listed shall be met. No possibility of damaged or worn out tools. Any soldering irons equipment systems shall provide temperature control isolation from EOS and ESD. Now calibration is one of the aspects. Most of the instruments will need calibration, and some of the crimping tools may be calibrated or validated. So mainly for class 3, the crimping tools shall have ratcheting mechanism so that you will have a uniform crimp force on a what you call when a crimp is performed, you will get a uniform or equal force every time. Pull test on sample crimps has to be done every time operator or tool is changed. So limited shelf life items shall be stored in accordance with manufacturer instructions, like any adhesive and other things which have expiry date. It has to be properly stored. Also, there is mixing and curing as per manufacturer's instructions. Material shall be used within the specified working time. That is, once mixed, there is a specific time within which it has to be used. Then equipment used for silicone. Silicone becomes a contaminant for other types of adhesive material. So if any material is used, any equipment is used for silicone mixing, that cannot be used for other types of adhesives. Of course, this is about the insulation removal, one of the first operations in a wire harness. There are three methods: chemical removal or thermal stripping and mechanical stripping. Chemical stripping has to be used only for single strand or solid wires, and thermal stripper may include laser stripping, which is the latest technology in that area. When stripping has been performed, IPC standard defines how many strands can be maximum damaged, allowable damage, basically. This is about the strand separation or spreading of strands. The limits have been specified for that. Separation normally for acceptable condition is separation not exceeding 1 strand diameter between the strands. Insulation, again, it could be damaged when you are removing the insulation. So if it is a thermal removal, it could also cause burning of insulation, which should be normally avoided. We should be rejected, basically. These are other types of damage which can be caused during the insulation removal. Coming to the length, of course, if the manufacturer has specified the length, you can follow that, or as per IPC, for a specified length, tolerance has been specified. The manufacturer will sometimes may not mention that tolerance for the length. In that case, you may have to follow what is given in this 620 standard. This table gives that. And while measuring what is the surfaces to be referred, for a straight connector, it is the edge of the connector. For a right angle connector, it is the corner of the connector which we have to take for taking the measurements of the length of the cable. So anyway, as per the length measurement, if it is within the limits specified by the customer user or as per the drawing, it is acceptable. And these are other types of terminals where the reference from where you have to measure has been specified here. So again, if it is within the tolerance limit, it is acceptable. Coming to crimp terminations, the main thing is whenever crimp is performed, there should be no damage to the plating or finish. Contact shall not have deformation, which may affect the form-fit function, and contact shall not be altered. Conductor shall not be cut or modified. So just to match the terminal, you are not supposed to cut some strands to match to the size. Also, multiple conductors shall not be twisted. No re-crimp or double crimp. Now coming to the matching of the terminal with the wires, you can, if there is a wire is a smaller size than the terminal, there is an option to increase the CMA buildup, what we call as CMA buildup. We increase the wire by adding multiple layers, either doubling the wire or adding fillers. We can increase the CMA to match the terminal. Again, coming to the contacts and lugs, tools to be used have to be identified on the documentation. Alternate tools can be used if you have objective evidence to show the validity of the tools. So coming to the mass termination here, after crimping, this is about the flat cables. Mass termination generally refers to crimping multiple wires in one crimping operation. That's why the term mass termination has been used. So after crimping, the cable connection has to be retained in the position and shall not be loose. Cable parallel to the connector face, cable protrusion beyond the connector face within one cable thickness. If it is a single wire termination, the wire end shown here at the edge here, it has to be 50% of wire diameter, the projection coming at the edge. And conductor has to be within the contact area here, and wire is in position within the retaining tabs. These are the edges here are the retaining tabs. So this is as earlier in the previous presentation, there was a discussion on, there was a presentation on gold removal. So again, as discussed earlier, gold surface, gold plating is not suitable for solder joint. It is very good for making a physical mating surface contact, but not good for solder joint. There is a small video here which shows that gold removal. So first melt the solder inside the cup there, and then remove it by wicking out the solder again. So that 2 times we have to remove the solder. It is called double tinning process. So 2 times you melt the solder inside the cup, gold surface cup, and the 3rd time we can insert the wire and solder. As discussed in the previous session, gold, when it mixed with solder, can form a intermetallic brittle layer, which again can crack under the vibration force. Coming to the tinning of wires. So when tinning, the same alloy has to be used for tinning and soldering. The tinning has to leave a smooth coating of solder. Outline of strands has to be discernible. So stranded wire shall be tinned when forming to a attachment or splices, except mesh. And stranded wire shall not be tinned when used in crimp termination, threaded fasteners, or mesh splice. So this is about, this slide is about the insulation clearance. Normally, a small amount of clearance is required. Minimum clearance is the insulation can touch the solder. Maximum is 2 wire diameter or 1.5 mm. So the general preferred wrap conditions are the wrap has to be parallel to one another. The heaviest or the thickest wire has to be at the bottom. Stress relief, whenever a wire is connected, there should be some amount of a looping done, so that again it will withstand any vibration or shock, mechanical stresses it will encounter. And the solder fillet around this has to be 75% minimum when it is having a wrap of 180 degrees here. Now this figure shows about the depression. This is generally a solder, insufficient solder, we can say. Some depth is formed here. That for class 3, the solder level has to be above this 25% R line. this edge has, this solder, what is you are seeing here is actually defect for class 3. It has to be above this line. So these are various connections to various different terminals. So this is for turret terminal, bifurcated terminal, slotted terminal, pierced terminal, hook terminal, and cup terminal. The ways how the wires can be connected to those. And the same type of terminals with the solder connection made, that is with the solder after the soldering process. Now, this is one of the aspects in harness where once the cable has been connected to a wires have been connected inside a connector, we use strain relief clamps, which will again hold the bundle and prevent any stresses or strains occurring on the cable, preventing its transfer to the internal connection. These two figures show routing where there should be no stress when the wires are exiting from the housing here, and no stress, sharp angle, it should not be bent in a sharp angle also. Contacts, no damage or bent contact is allowed. Contacts is to be positioned properly, inserted into position. So we can use the tools recommended by the manufacturer to insert the contacts into the location. And most of the time, unused locations may be filled with contacts or plugs. As far as marking is concerned, so normally as long as you are able to read, it is acceptable. Even if there is a slight blurring of the markings, if you are able to read, it is acceptable. In case of machine readable code like scanners reading code, it has to be read within, it has to be successfully read within 3 attempts. These are other types of markers where something, these like symbols or ID information can be printed on that. Coming to bundling or bundle formation of the cables. So the main purpose here is to have the bundle in a uniform diameter without variation in between. So cable lacing begins and ends with a locking knot here. Lacing is tight, wires are kept secure in a neat bundle. So these are other methods where branching is involved. These methods can be used, or cable ties, spot lacing can be done like this. Whenever there is a branching involved in the cable, double lock stitch has to be there at the beginning, first output, first branching, first breakout. And then single lock stitch has to be there before each of other breakouts here. And whenever 4 wires or more wires are breaking out here like this, we need to have a double lock stitch on both sides like this. Spacing from the breakout, if it's a bundle breakout like this, maximum is 3 diameters. Not more than 3 bundle diameters. You have to have a restraining device here. Again, these are different ways of bundle securing shown there. Generally, whenever bundle is formed, the wires have to be parallel in that bundle. And if there is any slight, the twisting or crossover, it has to be minimal, and bundle diameter must be approximately uniform. When a wire is bent or a bundle is bent, we have to follow the bend radius requirements that is given by this table in the standard. Coming to shielding, shielding is, the purpose of shielding is to prevent noise affecting the signals. So here, any braid, there are two types, directly applied and pre-woven. They have to be free of loops, no fraying or no opening up of the strands. Braid strands smooth and evenly placed. Braid overlap, when multiple braids are there, overlap 1 to 3 diameters of the largest bundle. Now the shield, as I told you, it will be meant for preventing the noise coming into affecting the signals. So effectively shield has to be grounded. So for grounding, various methods are followed. One of the method is by attaching a ground wire like this and then terminating this wire to the shield, ground point. That was by solder method, and this is by crimp method. When multiple shields are there, it can be daisy chained like this, and then one common ground can be terminated. Of course, when multiple grounds are there, it has to be staggered. That means it has to be in different locations so that diameter is not increased unnecessarily in one location. Now in this case, the shield is terminated directly on the connector body here. Again here two types are shown there. One is by shrink ring, where you place the ring on the shield above the connector body. Once it is heated and shrunk, it will change the color to black or brown. And the shield end of the shield has to be visible in the gap here. This is again by crimp method. After tightening this crimp, then the shield has to be visible in the gap between the back shell and the crimp ring. Here it is showing the termination of the wire to the ground, no stress with or sharp bend, and wire is within the envelope. That means within the connector outer boundary, within that area, it has to be turning like this and connected there. Shield can also be directly soldered on the connector if it is permitted by the documentation. Multiple shields to obtain electrical continuity, it has to be connected to one another. So it can be achieved either by soldering like this or by taping one above the other. Shielding can also be achieved by using a conduit metal tube. It is a tubular shape. It also acts as a protective covering and guide for wiring. Other types of protective covering are like fabric braid or nylon braid, jacket, an extruded jacket, spiral. Braid can be again directly applied. It may be loose or tight, smooth and free of gaps, and no stress on wires. Again, when branching is there is no gaps are supposed to be there here in the braid. In case of pre-woven, again, when multiple pre-woven braids are used, one above the other, the overlap has to be 1 to 3 bundle diameters. So anyway, this thing is much more exhaustive. The 620 is, I think we normally cover this in 3 days of training. So I could cover only little bit here. So thank you very much for this thing.
Okay, thank you very much, Mr. T.N. Panishai, for that presentation. It's going to be the last presentation for today. It's going to be a small one. So, the last presentation will be on latest technological soldering tools by Mr. Anand Selvaraj, who is the country manager for JBC Tools.
It's in presentation. It's not in presentation. I can. Oh, so many slides. How many slides is there? 54. I think I have shared you something else, right? No issues. Let me complete it. I will. Can you check? Because there's
See this one? This is one. Okay. Huh? But how you present this? Here. Is it right? No, this is not on. Manage. How to manage that one? I think you're not sent.
Hi everyone. Very good afternoon to everyone. So firstly, I'd like to thank the team IPC, EDB, and Sri Lankan Association for organizing such a good event. And we are very proud to be a sponsors for IPC EMI competition across India and also in Sri Lanka. And very special thanks to Mr. Lalit Bandara and University of Marathway and Department of Electronics and Electrical Engineering for organizing a great arrangement and great hospitality provided. Thanks. Okay, so all we are aware, all the electronics, modern electronics, now it becomes smaller and smaller and very compact. We can see the products, what we are using in current scenario. So if the products are getting smaller and smaller means the components, what we are going to use, and also the technology, what used in the PCBs, everything is going compact and compact. So there, JBC comes into the picture, because for reworking or repairing of those kind of products, it's such a great task. Even though it is a skill-based work, with the proper tools and proper trainings, it can be done in a very qualified way. So I just I just slow this.
Bandara, just excuse me.
But I thought I sent a different file to you, man. It's less, only 17 slides I sent.
IT guy. This is
I think I shared something
you do?
Yeah, it's very small slide.
It's okay to that. My email is on here. I can check anything. It is on there.
It's okay because it's a huge presentation. This is 54 slides.
What do you do?
I don't know how to do now. I have my computer. Can I take?
Hey, bring. Bring. Let him bring his computer. You remove that. No, you remove this computer. He'll bring this another computer. HDMI?
Yes, it's there.
Battery is there?
Should be. It's this side. Just a minute, I'll check what I have.
Wait.
This is also 54.
Wait.
Yeah, this is the side. It is okay. I can go fast with this.
Check. You use the remote?
No, it is this is presentation.
Where is your IT guy? You can do that. You can use that one. Put it something. Where is its IT guy? You can use that one. Switch off and switch on. I'm sorry.
If it is no time, it is okay. We can close it. No problem. Yes, sir. No problem.
Where is Bandara?
Basic things about JBC and our company. So JBC basically it's a Spanish company. The company originated in Barcelona by the year 1929. It's almost like 90 years old company, which is developing the soldering tools and soldering consumables for electronic industry. And we are one of the most advanced soldering stations with IoT futures, robotic protocols, and etc. from the last 10 or 15 years or more than 2 decades. So we have our direct offices or manufacturing site in Spain, and we have our direct presence in China, we have a direct presence in Germany, USA, India, Japan, and in other countries we operate through our distributors. And on the technology, JBC has a better heat transfer, effective heat transfer, which can able to reach 350 degrees Celsius or even more temperature at 2 to 3 seconds because of our technology. And instantaneous heat up, so instantly it can able to reach any temperature, which gives effective thermal recovery during soldering of mass PCBs or multi-layered PCBs or even a metal-clad PCBs. And it also increases your productivity by reducing the changeover time. The tips or the cartridges can be changed very fastly and effectively. And heat control, so as I told, it can able to reach 350 degrees Celsius within 2 seconds. Since our technology, all the heating elements, sensors, everything is put on the tip itself, on the cartridge. We call it as a cartridge. We can able to reach any temperature at 2 or 3 seconds. And the drop of temperature will be very linear. It means the temperature recovery will be much faster. It can recover in a fraction of seconds during the soldering joints. And we also have sleep mode futures, hibernation mode futures to reduce the oxidation, because tip maintenance is one of the important point while doing the soldering application. If the tip is not maintained properly, if it is too much oxidized, you cannot able to effectively transfer the heat. So we use sleep mode technology and also hibernation mode technology. Means when you are resting the handle inside the stand, it goes to the sleep mode. The temperature can be controlled. You can set any temperature less than the melting point of solder. And if you are not disturbing the tool, let's say for 10 minutes or more time, it goes to hibernation mode. So you save a lot of power, and also you save a lot of oxidation, which can improve your soldering joint. Because of our technology, where we keep the heating element and also the sensor inside the cartridge, we strongly recommend to keep lower the temperature compared to major brands, so that the quality of the soldering joint or the shininess of the soldering joint will be much better actually. And tip life, so the tip life is basically dependent upon what temperature you are going to use. So lower the temperature, you are going to increase the tip life. So with JBC, since you have hibernation mode, sleep mode, and other options, you can able to work at lower temperature, which will indirectly increases your tip life also. Cartridge changeover, most of the people would have been seen the cartridge changeover by the morning. So we can able to do the cartridge changeover without any external tools, just pulling and pull out. So it increases your productivity also. You don't want to stop the machine for changing the tips or nothing. And we also have a different kind of cleaning system apart from the sponge and the brass wool. It's an automatic tip cleaner, which is recently introduced, where we can able to keep the soldering iron just for once again. It effectively cleans the tip, and also it reduces the impact on the tip, because if you are using a brass wool, it depends upon the manpower. We can able to put more mechanical pressure, which can damage the plating of the tip. But here, since it's automated and since it's motorized, we just put inside the machine, which works with the sensor. It can clean the tip within fraction of seconds. And all the solder debris, everything will be stored inside the unit itself. So your work table will be very neat and clean. So I just introduced some of the products, starting with a new product range. So battery operated iron is a new series in JBC, which works with lithium-ion battery and very lightweight, around 15 grams or 20 grams. User-friendly for service environment and for R&Ds, where you have to switch the unit here and there. So it works with all the premium features of JBC, like sleep mode features, hibernation mode features, cartridge technologies, and everything. And the battery life can be, the battery warranty can be up to 3 years also. And for one full charge, it can able to go up to 100 soldering joint. And the benefit with this station, you can able to control this station with your mobile. Means it is Wi-Fi connected. You can set the temperature, you can operate the temperature, all the settings, everything can be done with your mobile, or you can buy with the display. So this is one of the new launch from JBC in this year. So these has 3 ranges actually. And the other one is the soldering assistance system. which is very useful in case if you are validating your operator. Because in this system, as Mr. Nagaraj sir was telling about the intermetallic layers and the time duration which is mentioned in the standards. Here what you can able to do is, as an engineer or as a manager, you can able to create a profile for your soldering job, a real-time profile based upon the power and the temperature. And when you are allowing your operator to repeat the job, the equipment itself says how much the operator is matching the profile. So you can validate, the machine can validate your operator, okay, he's matching around 70 to 80% of the profile. So the solder quality or the soldering job is better. So it's an indirect way of verifying or validating your operator. And our basic stations, we have 4 different basic stations with one of that you have seen on the top. So soldering, a tweezer type of station, solder feeder, and desoldering iron. These are all very basic stations. And we have a modular stations, single port, dual port, and 4 ports. So with 4 port, 4 people can work simultaneously, and it can be operated as a rework station. All 4 tools can be different tools, any of the tools shown in the image, and also all 4 people can work with the different temperatures with the highest futures. These 4 port stations has the futures like IoT. So in case, if you have so much of control in your company, you can able to control the system through your computer. You can set the temperature, you can monitor the temperature, everything from your computer. And it has the traceability features also, but that is additional software. So if you want to trace, if you want to include our system with your ERP or with your MES system, it is possible to do. And all our stations are robotic integrated. So if you have any XY table or gantry, our stations can adapt with their products actually, and it can be programmed as a robotic soldering station. And this is a very niche product which is very familiar with the semicon industries across the world. We are supplying to all the big semicon industries like Intel, Qualcomm, Cypress, Infineon, and everyone. It's called a nano product, nano station. So the weight of the handle will be something like 13 grams, lighter than our pencil or pen, and the handle will, the tip will be like smaller than a needle. So it can go in any small area to make a soldering job. So in semicon, we already started using O1, O005 components, which is the smallest component in industry now. We cannot able to even see with our naked eyes. Even that component, without damaging, we can able to do the rework with a nano station. It's a heavy-duty station, majorly used for metal-clad PCBs or solar panels or thermally challenging areas where high power or high demand is required. And these are our different types of hot air stations. We have nano hot air station, basic hot air station, and a powered hot air station. So all three work with the different powers, and it can rework the components from O1, O05, which we cannot able to see here, until a big BGA we can able to remove, and it's possible to place also with the practice. So these are the sizes of components we can able to do the rework. And wire stripper, since we are speaking about the thermal wire stripper, it's one of the options to remove any PTFE wires, Teflon wires, or Kapton wires without damaging, because when you are using a mechanical strippers, it may cut the strands, or the insulation may be not legible or not leveled. So with the thermal wire strippers, we have 2 versions. One is basic, one is precise, and one is normal. So you can able to do stripping of wires from 14 AWG to 36 AWG. And automatic soldering iron, this product is mainly, or it can be used where the places the third hand is required. So if you are making a soldering joint of a normal wire, or if you are making a soldering joint of a through-hole component where the third hand needs to hold the component or hold the wire, this is a good solution where you can able to load 1 kg of solder wire, and you can able to pre-program this machine. So how much length needs to be feed, how fast it needs to be speed, everything can be pre-programmed. And by pressing the pedal or by pressing the switch, that desired length will be there, and you are free with your third hand. And the preheater, it's basically for thermally challenged PCBs or metal PCBs where high power is required. You can able to preheat the board with the certain level of temperature which is recommended in standards and also the component manufacturer. Instead of going for a high temperature in the soldering iron, you can preheat the PCB with 80 to 120 degrees Celsius with combination of soldering iron at lower temperatures. So we have 4 versions from nano to the bigger size. The bigger size is around 500 to 600 cross. And it's a small product, solder paste, manual solder paste dispensing. For reworking area, you can dispense the solder paste through the manual dispenser. And it's a tip cleaner. We have 4 different models of the tip cleaner, automatic tip cleaner. One is manual, the other 3 are automatic tip cleaners. So it cleans the tip automatically and all the solder debris will be stored inside the machine. The fume extractor, we have a single port and also the 4 port. The advantages with our JBC fume extractor, if you are using a JBC soldering tools, the soldering tools and the fume extractor can be connected with RJ12. So when you are operating the machine, the fume extractor will automatically work. When you are not operating the machine, the fume extractor will also go to idle mode. So it saves a lot of power. Also, it won't collect the unwanted dust, and the life of the filters can be more also. And we do have the robotic soldering stations, desktop type. So for more details, you can visit our website also. And mainly the cartridges, since in the standards, we are speaking about different varieties of cartridges. JBC is one of the manufacturers has more than 400 varieties of cartridges. For each and every application, we have a niche cartridges. And we always do customization also. In case if you have a niche product where it needs a customization, we can do the customization also. So these are some of the cartridge shapes and sizes. And these are some of the special cartridges we already made for some different customers. And if you want to try our product, you have my number already. So you can contact me, and we are always ready to provide one machine for evaluation until 30 days trial. So once it's a successful trial, you can think of our product. Thanks for the opportunity provided.
Okay, thank you, Mr. Anand Selvaraj. Okay, now we have reached the it's probably the most important event for the today, is the announcing the winners of the today's competition. And there's a special announcement from Mr. Anand Selvaraj himself. The today's lucky winner will get an special gift from JBC Tools. That's an brand new soldering station worth 40,000 Indian rupees, probably around 150,000 LKR for the winner of this competition and the runner-up of this competition from JBC Tool. That's a special announcement. Okay, we're going to start up the announcing the winners by giving away the certificates for the participation of this competition. To give away the certificates, first I would cordially invite Mr. Manjulal Vas, the chairman of the advisory committee of EDB, to present here for the certification giveaway. I will call the names of the participants, and please come to the stage to receive your certification for their participation. Okay. Oh. Okay. And also we invite Mr. Akila Soisa, the Assistant Director of Export Development Board, also to be present at the stage, as well as Dr. Ranga Rodrigo, the Head of the Department of Electronic and Telecommunication, also be present at the stage. And finally, Mr. Gaurav Majumdar, the Executive Director for IPC India, to be present for the certification giveaway. So the first set of certificates will be given by Mr. Manjulal Vas. First, Shrimal Prasad Fernando, GP Vilanka Private Limited. Next, Pasindu Jayanayaka from Ray Engineering. Pasindu Jayanayaka from Ray Engineering. It's not there. Next, Akalanka Vijay Singh from High Tech Sensor Development Private Limited. Next, Indunil Eroshan Veeratna from Noratel International Private Limited. Janashan Nanayakar from Flintech Transducers Private Limited. Next, Nirma Anthony from Lanka Harness Co. Private Limited. Next up, Ashan Madhu Sankalpa Fernando from GP Vilanka Private Limited. Netsan Narasinghe from One Smart B Private Limited. Bandara Samarkon from High Tech Sensor Developments Private Limited. Ravindu Vijaykorn from Ray Engineering. Ravindu Vijaykorn. Okay, it's not there. Manoj Tushant from Vario Systems Private Limited. Dinesh Hulangamua from Noratel International Private Limited. W. Nouri Fernando from GPV Lanka Private Limited. Tilina Sugandhika Alvis from Flintech Transducers Private Limited. Next, Tilini Kumari from Vario Systems Private Limited. HCC Haturu Singha from High Tech Sensor Developments Private Limited. WAUK Vijay Singha from Noratel International Private Limited. Shashani Pavitra Ranavira Silva from Flintech Transducers Private Limited. K.A. Nuan Shalika, Magic Bit Private Limited. NKLTMS Dias from Aximt Electronics. Nuan Prasanna Disanayaka from Toslanka Private Limited. And finally, Malsha Sewandi Fernando from Lanka Harness Co. Private Limited. Okay, thank you very much for all the distinguished guests. So now all have received their certification for the participation. Out of these 22 competitors, someone will have become the winner and the runner-up. Even I don't know who the winner and runner-up. Only Mr. C.S. Nagaraj will give away that information. So I invite Mr. C.S. Nagaraj to announce the winners of this competition.
Before we announce the results, it's our duty to thank the observers who have helped us from morning till evening. So I would like to I would request our Executive Director, Mr. Gaurav Majumdar, and Mr. Anand from JBC to come out to the dais to hand over the participation certification to the observers who helped us. First, Shashika bin Fernando from Flintech Transducers Private Limited. Mr. Mudita Prasanna from Vario Systems Private Limited. Mr. Milroy Pereira. Mr. Susanta Vikramarachi from Vario Systems. Mr. MMM Ravindra from Vario Systems. Mr. Kasun Samarasinghe from GPV Lanka Private Limited. And finally, above all, Mr. Lalit Bandara from JPV Lanka, who has helped us a lot. Now the time has come. Before, once again, I announce the results. It was very well participated. Out of, there were 24 registrations. Out of 2 people could not, unfortunately, attend. 22 of them attended from 11 companies. So I should thank the companies who sponsored their employees to take part in this competition. And the observation from the judges' side and even the observers' side, there are a lot of scope for improvement. This is what I want to tell. And we have selected the best out of the 22, the top 2 out of 22, who could complete the assembly within the stipulated time. And the board was functionally tested and it was functioning very well. So as I said, there is again a lot of scope for improvement. And don't stop at this. I expect that all the participants will once again participate in the future days to come and always try to again compete and try to win the prizes for their company and themselves. With that now, I am going to announce first the runners. The runner, yeah. I will call upon, Executive Director, Mr. Majumdar, and, and other dignitaries to be on the stage with Mr. Anand from JBC. The evaluation was done as per Class 3 of IPC requirement. The margin from from the runner to winner was very narrow. In fact, we had a tough time in actually evaluating it. So, let me announce the runner. The runner is Mr. Srimal Prasad Fernando from GPV Lanka. Who can be the winner? Any guess? Who can be the winner? Who is going to win? Okay. The winner is wait, let the winner also come. The winner is Mr. Manoj Dushanta from Vario Systems. Mr. Manoj Dushanta has set a new benchmark. He has completed the task within 40 minutes. The time taken by him is 40 minutes compared to the others. So I once again ask all of you to give him a big round of applause. Now I request Mr. Anand to hand over the prize to the runner and the winner. Observers?
Sir, please.
Please come over. Observers? all see you. Please come.
ಆಯ್ತಲ್ಲ ಮತ್ತೆ ಸೊ ಅವ್ರಿಗೆ ಕರಿಬೇಕು
ಅದೇ ನಾನು ಕರೆದೆ ಹೇಳು.
ಭಂಡಾರ
ಪ್ರೆಸೆಂಟೇಷನ್ಗೆ ಕರಿಬೇಕು.
ಭಂಡಾರ